Hi, this is Shakil Ahmed. We are now discussing the video 4 of Shiny app development. In this video, we will discuss about basic reactivity that the server function does. Server functions take three parameters: the input, output, and session, and it basically updates the output based on the input. And if you see, we have two things: UI and server function. UI is basically front end interface where what you can see on the front end, what should be the input a user uh, can enter and what he or she can see on the screen. And the server function basically does the background task. So whenever you change your input, the user change the input, the output will be automatically changed. And this is called the reactive programming. How the output reacts when you change the input. We will discuss this, and we will give a simple example uh, how the reactive programming works. So the render function basically does the two things as I have already discussed in previous video. It sets up a special reactive context that automatically track what input the output uses, and it converts the output of your R code into HTML, and that can be stable for the web page. Basically, you are showing through a website and on internet, so it should be displayed on the website through HTML. So the render function does this thing. And if you can see, for example, we are setting a text output that is greeting, and we ask the input, output, and session. So the output greeting means hello human. We have just given the greeting, and we are just getting an output. We have not yet entered any input. But in this example, we can see this is called declarative programming. Declarative programming we will discuss later, but I'm just telling. And declarative programming, in declarative programming, we just give the things, or we just tell someone to do a specific task, and we give the basically a recipe for anything a person want to make. So I'm just giving the recipe and basically the procedure, and the task will be done accordingly. But the a classic programming that is called uh, the you can see, I just forgot, imperative programming. So imperative programming, uh, we just give a specific command and it's carried out immediately. That we do in our studio. Basically, we just ask to find a plot. We just ask to perform a test, and that will immediately we will see the result. But in declarative programming, you just describe the importance of constraint and rely on someone else to decide how and when to translate that into action, and that is based on certain constraint. So this is called a reactive programming, that based on declarative programming instead of imperative programming. So here you can see in this example, the output changes whenever you change the name of a person. For example, here you can see I just name as Aslam, then uh, what is the person enters his name as Aslam, then the greeting is changed accordingly with the name Mr. or Mrs. Aslam. So whenever the name change, the greeting will be changed accordingly. So this is called a reactive programming. This output is changing according to the input. Whatever input the user gives, and the output will be displayed accordingly, will be changed accordingly. This is called the reactive programming. How output reacts when and the user change the input. So we will see this in our R codes. We are just copying the user interface and the server function, and let's see. I'm just copying here. I think if everything is okay, we can go. Basically, we are giving a text input, that is, we are asking user to enter their name, and the text output greeting. And this is we are giving the greeting. Basically, we are just writing a greeting. The greeting text we are already given, but the second output, that is dependent on the input what the user is giving. So the user, whenever user enters his or her name, the greeting will be changed accordingly. This is called the reactive programming. And let's see this one. Need to stop the previous one, and then we can see. So what is your name? So if I write my name Shakil, it will change accordingly. Hello, Mr. Shakil. And if you enter any other name, for example, ABC, it will change accordingly. So this is called reactive programming. Whenever the user change the input, the output will automatically change according to the input. That is, we will say the reactive programming in R. So the reactive programming, just the name, and this is convert into string, and then it will give a greeting. So this is called a reactive graphic graph. You can make a reactive graph for most of your programming on Shiny app. You can just make a reactive graph, how the program changes whenever you change the output changes whenever you change your input. So here is an example. In this example, we generated data from for two groups, x1 and x2, from normal with different parameters, and display the two distribution using frequency polygon, and using the ggplot2 package, and apply a t-test using and see how reactive programming works in R. Basically, we for the simulation study, we are specifying the parameters of the x1 x2 for a normal distribution, and we need also to enter the sample size, what sample size we need to set for the two groups, and then how the t-test can be performed, and how we can display the data. So these are things we are going to do in this reactive programming. So I have the codes on my GitHub. I usually share my codes on code links on the in the comments of the videos. If you want to see, you can just check. So you need to first define the function, the frequency polygon function, and the t-test function. So I'm just specifying the frequency polygon function, and this is the Shiny app, and this is the ggplot package, and I am creating a function that is called frequency polygon. Just I named it as frequency polygon, and the function, uh, the inputs are the x1 x2, and the bin width means size of the bins, that is you can change accordingly, but here it is fixed at zero point 0.1, although we give our users an option to change this as well. And the x limits of the limit of the x-axis, that is set to -5 to 5, and the data frame consists of x, the two variables which we need to generate from normal distribution, and the g means grouping variable. It will give a repeat x1 for length x1 and repeat x2 for length x2. So we are writing x1 first and then x2 first, so, on second. And then uh, ggplot, uh, we need this is just function of ggplot you usually use, and you need to specify the data frame and the aesthetics, that is x, and the color is g, means we are displaying the two distribution with uh, two different colors, and we are displaying the frequency polygon with bin width, that is we have already displayed, and the size is 1. You can increase the size, that is the size of the curve, and the coordinate Cartesian limits, that is x limit, we need to set the limit of the x-axis. So you can just run this function, although we have no input, so this function will not give any output. We can just run this, and the second function is the t-test function, and that is also conducted on the same data, and we are specifying the t-test. T-test, that is also function of x1 and x2, and t-test x1 x2, basically we have two groups x1 and x2, so we just perform the t-test, we can just perform the t-test. And this function sprintf is used to display the data in this format. It will provide the p-value and then colon and the uh, confidence interval uh, in this format. So test confidence interval 1 and test confidence interval 2. So we can use just this command, although you can display it in terms of a table. In that case you need to change this the output type as table in your output function in your UI as well as in your server function, but here we are displaying it in sprintf, and it will be displayed in a verbatim text format. That is just an output in terms of ports. So let's see. So we have specified the t-test. This will give your p-value, and this will give the lower confidence limit, and this will give the upper confidence limit. And then we are now generating a data set. These are the, we are just checking whether these functions work or are working or not. You can just run the two data, and you can just see whether these functions are working or not. Simply check the frequency polygon with the two inputs x1 and x2, and the other things will be set by default. For example, bin width and x limit will be set as by default, this one and this one, if you are not specifying here. If you can specify here, then you can, then the result will be changed accordingly. So let's see. So this is the frequency polygon we can see for this data set. And this is just printing the result of t-test in terms of available team text. So that is used as get command. Sorry, I think we have not run the t-test. So we need to run this and then we can display the results. So this is the verbatim text format. Here we have the p-value 0.007 and the confidence interval. So that's all about the two functions. Now we will go toward the uh, interactive programming using the UI and the server function. We are going to display the uh, float page with float row and float and within float row we have different columns. So we have first row, we have second row, and we have two rows. In first row we have how many columns? One, two, three columns, each of size 4. And in second row we have only two columns with size 9 and size 3. So you need to display these things. And we can in the first column we have the three things. First, the distribution. This will be written on first, and then numeric input. We need we will ask uh, we will be asked to enter the sample size and mean one and standard deviation one in column one, and in column two we need data for the distribution two, and in the third column we will get the frequency polygon of the first row. And we again ask to enter the bin width size and the x limit range, although it's by default it's -3 to 3, and in above the function we have set it to -5 to 5. So we need again minus, I think the minimum and maximum value is this, and the values are coming in this range, so it's okay. And then in second row we will display the column with plot output, that is the histogram, and the second team text with t-test. These are the two outputs. So in second row we will get the outputs. In first row we are given option to different inputs, and in second row we are given we can see the two types of outputs. And the server function, how the server function connects. Now we have two things. One, the histogram output, and that is called output hist, and you have already specified it here. And the second is a t-test output, you have specified here. And within histogram output, the render plot option we will display the two plots, and uh, we will just get the x1 and x2 that are based on different inputs. So x1, whenever inputs change, the axis change, and whenever axis change, then the plot will be changed. So this is called the reactive programming. The inputs axis are dependent on n1, mu1, and standard deviation 1, and the frequency polygon depends on the x1 and x2. So basically the output ultimately depends on the inputs. Similarly, in for t-test, we have again x1 and x2 can be specified through n1 and mu1 and sd1, and the uh, t-test depends on x1 and x2. So ultimately, the output depends on the two inputs. Whenever the user change the inputs, the simulation work will generate different random numbers and the with different distribution, and the result will be changed. So let's copy these codes the UI and the server and the final shiny. So I'm just copying below the given text and check if there is any mistake in the codes. So now you can just run the codes. Here are the results. This is the first row. Here we can see, for example, I'm just shifting it here. This is distribution 1 and this is distribution 2 and this is frequency polygon. So we need to enter, and these are by default values of the inputs, and we can change. For example, if I want to change it to 10,000, I will just change it. So now it's more nearer to more, we will get a more flat distribution. This is for n1, and if you change this one, this will also give the no, not flat one, not more nearer to the normal distribution. And if you want to shift the means, for example, mean to 6, the mean will be shift on the right side, and you can also change this mean. So it's not showing as we have set the range in -2 to 2, so it's not displaying. But if you can change it to 0.5, it will display just a little bit to the right. This is 0.5. So if you want to change the sigma to 0.9, there is a higher variation in the data too. And if you want to change it to 0.7, you can see. And you can change the range here. For example, -3 to, instead of -3 to 3, you can set -5 to 5. And you can change the bandwidth size of the histogram. These are the bandwidths. You can just change it, for example, changing it to 0.02, for example. Let's see. So it's more zigzag, as the histogram are based on smaller bandwidth size, bandwidths. And this is the result of the t-test. Whenever you change the mu, although it's not significant, if I change it to, for example, the mean uh, 0.9, now it's significant. There is a significant difference between the two means of the two normal distributions. And the samples, if you decrease the sample size, then the significance will be changed. If I further, and I will just set it to 0.2. So it's still coming significant, as there is the difference is high, and the standard deviations are approximately same. If the standard deviation are different, then we will need to test the we will use to apply the Welch test instead of simple t-test. So this is what about the interactive programming, reactive programming. Whenever you change the inputs, the output will react accordingly. So thank you. If you have any question, you can always write in the comment box. I will try to share the codes in the comments as well. You can just practice, and you will learn how to program, how to make program for a reactive shiny app.